Assalamualaikum warahmatullahi wabarakatuh, and a very good day to our respected lecturer and fellow friends. We are from Group 1, and today we will present our mobile cloud computing group project entitled EcoTrack, Smart Mobile Application for Campus Recycling and Thrift Management using Rule-Based Automation and Cloud Computing Services. My name is Rina Damia binti Azrin. Together with me are Farisa Atira, Sarah Idina, and Nur Nelly Atira. Today, we will explain how EcoTrack combines multiple cloud services and our own custom backend web service to create a complete cloud-native mobile application. Malaysia continues to face challenges in encouraging recycling among university students. Although recycling bins are available on campus, participation remains inconsistent because students receive little motivation. There is no centralized recycling record and recycling activities are difficult to monitor. Besides recycling, many students also buy and sell second-hand items through messaging application. However, these transactions are often unorganized, difficult to track, and lack a secure payment mechanism. Therefore, our team developed EcoTrack. EcoTrack is an Android mobile application developed specifically for university students to manage recycling activities and thrift marketplace transactions in one platform. There are several problems identified in this project. First, students do not have a centralized platform to submit recycling evidence, track their recycling history, or receive rewards. Second, recycling activities and second-hand transactions are often managed through different platforms, making the process difficult and unorganized. Thirdly, thrift transactions through messaging application may not provide proper payment records, digital receipt, or seller ratings. Lastly, without rewards, competition, and proper monitoring, students may not remain consistent in recycling activities. So, to solve these problems, EcoTrack combines two major modules. The first module is a recycling management system. Students can submit recycling evidence, upload proof images, earn reward points, view recycling history, and compete through faculty leaderboards. The system also applies rule-based automation for recycling validation, reward point allocation, and leaderboard generation. The second module is a thrift marketplace. Students can buy and sell second-hand items, communicate with sellers, complete online payments, receive digital receipt, and rate sellers after a successful transaction. The main target users of EcoTrack are university students. Students can use the application to manage recycling activities, collect reward points, join faculty competition, and perform thrift marketplace transactions. The application also supports university administrators who manage submissions, users, competition, and marketplace activities. Overall, EcoTrack provides a centralized, secure, and organized platform for campus recycling and thrift management.
Thank you, Ms. Norina. Now I will demonstrate the first part of the EcoTrack application. As mentioned earlier, EcoTrack is a cloud-integrated Android application. Every important activity performed by users is synchronized with cloud services in real time. First, I will create a new user account, click register, and fill in the name, email, password, and faculty. For example, name is Siti Farisa. Siti Arifah. And then email arifah@gmail.com. And then just fill in your password and select your faculty. Then click register. Once registration is successful, EcoTrack automatically creates a new authenticated user account. Here we can see that the account has been created successfully inside Firebase Authentication. Firebase Authentication is responsible for securely managing user identities. Instead of storing password inside our application database, Firebase Authentication encrypts the user credentials and handles the login process securely. This approach improves the application security while reducing the complexity of authentication management. After registration, every user receives a unique user ID or UID, which is later used throughout the entire application. After logging in, the user is redirected to the EcoTrack dashboard. From this page, user can access recycling module, recycling history, faculty leaderboard, marketplace, competitions, and user. I will first demonstrate the recycling submission feature. Now, the user selects the waste category and then select the quantity, for example, 3. Then the user enters the weight of the recycled material, for example, 1.5. Next, the user can fill in the description if they want and uploads the recycling proof image. Then the user can click Submit Recycling and the submission has now been uploaded successfully. I will first demonstrate the recycling submission feature. Now, the user selects the waste category and then select the quantity, for example, 3. Then the user enters the weight of the recycled material, for example, 1.5. Next, the user can fill in the description if they want and uploads the recycling proof image. Then the user can click Submit Recycling and the submission has now been uploaded successfully. I will first demonstrate the recycling submission feature. Now, let us see what happens in the cloud. Every recycling proof uploaded by users is automatically stored inside the Firebase Storage. Firebase Storage provides secure cloud storage specifically designed for mobile applications. Instead of saving image inside the Android device, EcoTrack stores them securely in the cloud. Only the download URL is safe inside the database, making storage more efficient and scalable. Now, let us see what happens in the cloud. Every recycling proof uploaded by users is automatically stored inside the Firebase Storage. Firebase Storage provides secure cloud storage specifically designed for mobile applications. Besides storing the recycling image, EcoTrack also stores all submission information inside Firebase Realtime database. The database records include user ID, faculty, waste category, weight, image URL, submission status, timestamp, and many more. This cloud database synchronizes the data almost instantly, allowing administrators and users to see updated information without manually refreshing the application. This real-time synchronization is one of the main advantages of cloud-based mobile. The newly submitted recycling record immediately appears inside the recycling history page with a pending status. This demonstrates how Firebase Real-Time Database provides immediate synchronization between the cloud and the Android applications. Once an administrator reviews this submission, the status will automatically change without requiring the user to manually update the application. This completes the first half of our live demonstration. Next, member 3, which is Ms. Farisa, will continue by demonstrating the administrator verification process, leaderboard updates, marketplace features, secure payment integration, and our custom in-house RESTful web service. Thank you.
Okay, now I will switch back to our student account. Okay, we log in using the email and also click on the fill in the password, then click the login. Okay, this is our student interface. Now we scroll down and click on the leaderboard. Okay, as you can see here, after the administrator approved the recycling submission, the student with 3 points are updated. Without user, the student need to manually refresh it. So this real-time synchronization is one of the key advantages of using our cloud databases in mobile application. And then next, we click back and go to the marketplace, and I will explain a bit about the marketplace pages. So this is our pages where the student can browse the second-hand item uploaded by the other user. So each item will display the item image and prices, seller information, and also class rating. Just click on any product. For example, this will go in during the ITM 3. So you can see the item detail here, and you can either buy the item or chat the seller. For example, you want to chat the seller, so you can ask anything that you want. You can ask anything that you want. For example, you want to ask if it's still available or not. So you click on send, then send it, or you can just check out the item, click on buy item. And here this is the checkout page where you have to fill in the detail, the payment detail. Okay, first the card number, and then you can fill in the date and expired, the name of the card. Next, after you fill in all the detail or the payment detail just now, then I will explain about what happened after that. So we are using strict test mode. So when the user clicks on the pay now, the Android application does not communicate directly with the Stripe. Instead, it will send the HTTP post request containing the information in JSON format to our own custom RESTful web service named create payment intent. Okay, so this custom web service was developed by our team and is implemented using Firebase Cloud Function, which are deployed on Google Cloud Run. Okay, we open the Google Cloud Console. Okay, Cloud Run, and select the create payment intent. So this is our deployed serverless backend. Whenever a payment request is received, then the REST API performs several business logic operations. First, it will validate the payment request. Then next, it converts the payment amount to Malaysia ringgit into the smallest currency unit required by Stripe. And finally, it will secure communicate with the Stripe REST API using the Stripe secret key and keeping the secret key inside the backend improve application securely because sensitive credentials are never exposed inside the Android application. Now we go to the Stripe dashboard. So you can see here there's a payment and there's a transaction. So this is all the transaction that happened. And this is the payment intent ID. We go back to the Stripe dashboard and you can see the same payment intent ID description at the Stripe. So it shows that the payment intent generates a secure client secret, which is written as the JSON response to Android application. And the Stripe Android SDK then completes the payment securely without exposing the confidential payment information. After the payment completed successfully, the EcoTrack will automatically generate a digital receipt containing the transaction detail. You can see the amount paid, the payment method, the status, and also the date. Okay. Next, you can view the transaction history. This is all the listed transaction history. Okay, and also you can rate the seller, giving the rating and then submit rating. Okay, after that you can see the item is marked as sold, so it will prevent others from purchasing the same item again. Okay, that's all from.
Thank you, Ms. Farisa. So after demonstrating the complete EcoTrack application, I will now briefly explain our cloud architecture, followed by the challenges we encountered and the lesson we learned and our conclusion. So the architecture of EcoTrack follows a modern cloud-native mobile applications architecture where the Android application communicates with several cloud services to provide a secure, scalable, and a real-time user experience. So, starting from the mobile application, users interact with features such as recycling submission, thrift marketplace, competitions, and payments. For user authentication, EcoTrack uses Firebase Authentication. This service securely manages user registration and login while generating a unique user ID for every user. So, application data such as recycling, submission, leaderboard rankings, marketplace listing, chat messages, competition, user profiles, and transaction records are stored inside the Firebase Realtime database, allowing data to synchronize instantly across all connected devices. Images uploaded by users, including the recycling proof images and marketplace product photos, are stored securely in the Firebase Storage, while only the download URL is stored inside the database to improve storage efficiency. For online payment, the Android application sends an HTTP post request to our custom in-house RESTful web service called Create Payment Intent. So this REST API is implemented using Node.js with Firebase Cloud Functions, the second generation, and deployed automatically on the Google Cloud Run. It securely communicates with the Stripe REST API using the Stripe secret key. So this creates payment intent and returns a client secret to the Android application. This architecture ensures that these sensitive payment credentials remain securely on the back end instead of being exposed inside the mobile application. So overall, this integration of the cloud services allow EcoTrack to provide a secure, a more reliable, scalable, and cloud-native mobile application. Throughout this project, our team encountered several technical challenges. So the first challenge was to integrate multiple cloud services into one mobile application while ensuring that all services communicated correctly. The second challenge involved designing and deploying our own custom RESTful APIs web service. Since this was our first experience developing a serverless backend, we needed to understand the HTTP communication, JSON request and response handling, and also cloud deployment. Another major challenge was implementing secure payment processing. We had to ensure that the Stripe secret key remained protected by placing it inside our backend rather than inside the Android application. And finally, synchronization data in real time while maintaining application stability required careful testing throughout the development process. This project provided valuable experience in mobile cloud computing. We learned how multiple cloud services can be integrated into a single mobile application to create a complete cloud ecosystem. We gain practical experience using Firebase Authentication for secure user management, Firebase Realtime Database for a real-time synchronization, Firebase Storage for cloud-based image management, and Stripe Payment API for secure online payment processing. In addition, developing our own in-house RESTful web service strengthened our understanding of back-end development, REST APIs, JSON communication, serverless computing, and also cloud deployment. Beyond technical skills, these projects also improved our teamwork, project planning, problem solving, and software development practices throughout the project lifecycle. In conclusion, EcoTrack successfully demonstrates a complete mobile cloud computing solution by integrating multiple third-party cloud services together with a custom in-house RESTful web service. The application provides secure user authentication, real-time cloud synchronization, cloud-based image storage, secure digital payment, and a scalable back-end architecture that supports future expansions. More importantly, EcoTrack fulfills all the technical requirements of this mobile cloud computing project, including the development of a native Android application, the integration of multiple third-party cloud services, and the implementation of a custom cloud-hosted RESTful web services. We believe that EcoTrack has the potential to encourage sustainability recycling practices while providing students with a convenient and a more secure campus thrift marketplace. That concludes our presentation. Remember, recycle smarter, compete greener. So thank you very much for your attention, and that's all from us. Thank you.